Okay, today's video is going to cover the parts of a circle. So this is our beginning. This is a circle. A circle is a special type of geometric figure. All points on a circle are the same distance from a center point. And our center point is drawn here in the middle, right there. The measure of OA and OB are the same. That is OA, and that should be a little congruent symbol down there, is to OB. All radii are going to be congruent to one another. So OB is a radius, OA is a radius, in plural, the name is radii. A circle is the set of all points in a plane that are a given distance from a given point in the plane, called the center of a circle. Note, a circle is named by its center, so the above circle is named by circle P. So the center point of the circle is the name of the circle. There are three kinds of segments related to circles. A blank is a segment whose endpoints are the center of the circle and a point on the circle, as illustrated down below. That's going to be a radius. A blank is a segment whose endpoints are on the circle. Okay, so here we have a segment whose endpoints are on the circle, as illustrated below, and that's a chord. And a blank is a chord that contains the center. So we have a special type of chord that runs through the center of the circle, and that is called a diameter. Segments of a circle. We have a radius. KA is the radius of circle K. We have a chord. JR is a chord of circle K. And we have a diameter. GT is a diameter of circle K. From the figures, you can note that the diameter is a special type of chord that passes through the center. Use circle Q to determine whether each statement is true or false. AD is a diameter of circle Q. I'm going to say that's false because I see AD is here, and in order for it to be a diameter, it has to go through center point Q. So that is false. Segment AD does not go through the center Q. AC is a chord of circle Q. Well, a chord is defined as having a segment whose endpoints are on the circle, and that does qualify. So that is true. AD is a radius of circle Q. Well, I know a radius has to start at the center and be a point on the circle. And since AD does not have a point at the center, I'm going to say that's false. And it is false. Note 1, all radii, which is plural for radius, of a circle are congruent. The measure of the diameter D of a circle is twice the measure of the radius R of the circle. So D equals 2 times R. Or if we go the other way, a diameter is twice a radius, so the radius is half the diameter. Because all circles have the same shape, any two circles are similar. However, two circles are congruent if and only if their radii are congruent. Two circles are concentric with the same center. Con means with, centric means center. If they meet the following three requirements: they lie in the same plane, they have the same center, and they have radii of different lengths. It's like when you throw a pebble into the pond or a lake, when you see the ripple effects, those are concentric circles. circle R with radius RT, and circle R with radius RS are concentric circles. Arcs and central angles. A central angle is formed when the two sides of an angle meet each other at the center of a circle. Okay, so our central angle would be at angle TRS. That's where the two sides of an angle meet at the center of a circle. Each side intersects at a point on the circle, dividing it into arcs that are curved lines. So the arc would be from T to S, just that part. There are three types of arcs. A minor arc is part of the circle in the interior of the central angle with a measure of less than 180 degrees. So our red line here, that would be a minor arc. It is contained within the central angle. It's called an intercepted arc, and it is less than 180 degrees. A major arc is a part of the circle in the exterior of the central angle. So now we have our orange line here. And semicircles are congruent arcs whose endpoints lie on the diameter of the circle. So here we have a semicircle in red and we have a semicircle in green. So we have minor arc PG, and the measure of arc PG is less than 180 degrees. We have major arc PRG, and note that it does have three letters. You have three letters to give you a starting point, a direction to move in, and an ending point. So it's telling us the arc is starting at point P. We're going to go along point R, and we're going to end at point G. So the measure of arc PRG is more than 180 degrees. And our semicircle is considered a major arc, so we have three letters. Again, a starting point, P, a directional point, go in the direction of R, and an ending point, T. So the measure of arc PRT is 180 degrees. Note that for circle K, two letters are used to name the minor arc, but three letters are used to name the major arc and semicircle. These letters for naming arcs help us trace the set of points in the arc, and this way there is no confusion about which arc is being considered. Depending on the central angle, each type of arc is measured in the following way. The degree measure of a minor arc is the degree measure of its central angle. The degree measure of a major arc is 360 degrees minus the degree measure of its central angle. And the degree measure of a semicircle is 180 degrees. Let me go back. Okay, so what this means is that whatever the measure of that central angle is, that's going to be the measure of the minor arc. Minor arcs and central angles are congruent. Major arcs, you could use arc addition on this too. If you have smaller arcs that make up your larger arc, you can add up the smaller arcs. Or, like it says here, you could take 360 degrees minus the measure of the central angle and get the major arc. And semicircles is half the circle. A circle is 360 degrees, so half of 360 is 180. A semicircle is always going to be 180. In circle P, arc AM and arc AT are examples of adjacent arcs. Adjacent arcs have exactly one point in common. For arc AM and arc AT, the common point is A. Adjacent arcs can also be added. So the sum of the measures of two adjacent arcs is the measure of the arc formed by the adjacent arcs. So if we were to add up arc AM and arc AT, that would give us 126 degrees, and that would be arc MT. If Q is a point of arc PR, then the measure of arc PQ plus the measure of arc QR would equal the measure of arc PQR. When the table's top is open, its circular top is said to be what about the square? Circumscribed. Circum means to go around, scribe means to write. So it's written around the square. We also say that the square is inscribed in the circle. So in meaning inside, scribed means written in. So written inside the circle. A polygon is inscribed in a circle if and only if every vertex of the polygon lies on the circle. So all 4 points of the polygon, or in this case our square, have to be touching the outer edges of the circle. Some regular polygons can be constructed by inscribing them in circles. Inscribe a regular hexagon, labeling the vertices A, B, C, D, E, and F. Construct a perpendicular segment from the center to each chord. From our study of regular polygons, we know that the chords AB, BC, CD, DE, and EF are congruent. From the same study, we also know that all of the perpendicular segments are called apophthegms, and they are congruent. An apophthegm is a segment that goes from the center of a circle perpendicular to a side of a polygon. Make a conjecture about the relationship between the measure of the chords and the distance from the chords to the center. The chords are congruent because the distances from the center of the circles are congruent. An inline skate advertises 80mm clear wheels. The description 80mm refers to the diameter of the skate wheels. As the wheels of an inline skate complete one revolution, the distance traveled is the same as the circumference as the wheel. Just as the perimeter of a polygon is the distance around the polygon, the circumference of a circle is the distance around the circle. In the previous activity, the ratio of the circumference C of a circle to its diameter appears to be a fixed number slightly greater than 3, regardless of the size of the circle. The ratio of the circumference of a circle to its diameter is always fixed and equal to an irrational number called pi, or we have the pi symbol, or circumference equals pi times diameter. Since diameter is equal to 2 times pi, the relationship can also be written as 2 times pi r. So C over D is equal to pi, circumference over diameter. If a circle has a circumference of C units and a radius of R units, then C equals 2 times pi r, or diameter times pi. If a circle has an area of A square units and a radius of R, then A is equal to pi r squared. And we just substitute in our radius into the formula, square it, and multiply it by pi. If we have the diameter, then we need to take half the diameter, square it, and multiply it by pi. And we're done.